In this video, we're going to talk about the last type of transformation we're going to discuss, and that is a dilation. Dilations on the coordinate plane are a transformation that enlarges or reduces a figure by a scale factor. So all of our other transformations did not change the size of the shape, only changed its location or orientation, much like the translation you see here. That was a slide where we just moved the shape from one place to the other. A reflection, that was a flip over a line of reflection. Again, the size stayed the same. But now we have a dilation where you can see that an image is going to be either enlarged or reduced in size. So how do we perform a dilation on the coordinate plane? We're going to use what's called a scale factor, and we're going to call that scale factor K. Okay? Okay. How to perform a dilation on the coordinate plane. So dilations are performed by multiplying K by every ordered pair, where it's just going to be a multiplier, really. So our scale factor is a multiplier. We're going to multiply the ordered pairs by the scale factor. So every number in our ordered pair is going to get multiplied by the scale factor. So if you'll look here, here's a nice key to those scale factors. Anything larger than 1, any scale factor that's larger than 1 is going to produce an enlargement. It's going to enlarge the shape. Anything between 0 and 1, any scale factor between 0 and 1 is going to be a reduction. It's going to make the shape smaller. And if your scale factor is exactly 1, that is going to be the exact same size. It's not going to change the size of the shape at all. And notice that K, or our scale factor, can never be negative. You're not going to have a negative scale factor. So let's take a look at a couple examples here of a dilation. So here we have triangle ABC, and we want to dilate this triangle using a scale factor of 2. So what do you think is going to happen to this triangle? Is it going to get bigger, or is it going to get smaller? Well, this triangle is actually going to get twice as large because our scale factor is 2, which is greater than 1. So this is going to cause an enlargement. So how do I enlarge this triangle by a scale factor of 2? I'm going to multiply every ordered pair by 2. So my A prime would become 4, 2, which would be right here. My B prime would be 6, 8, which is right here. And my C prime would become 10, 4, which is here. So those are my vertices of my triangle, and let me connect these here. And you can see we have produced the exact same triangle, only larger. And more specifically, it is now twice as large. So triangle A prime, B prime, C prime is a replica of triangle ABC. It is just now dilated or twice as big as the original. Here we have a quadrilateral, and we want to graph the image after dilating the figure with a scale factor of 1/3. So now we are going to reduce this object. We're going to shrink it. So how do we do that? We're going to apply our scale factor, which is 1/3, to all of the ordered pairs. So -3, 9 would become -1, 3. 6, 3, or my R prime, would become 2, 1. S prime would become 3, -1, and T prime would become -1, -1. So if I plot all of these points, my Q prime is at -1, 3. My R prime is at 2, 1. My S prime is at 3, -1. And my T prime is at -1, -1. And again, if I connect my points here, I'm going to have a quadrilateral that is identical to the original, only smaller, a smaller version of it. by a scale of 1/3. So this new shape is now 1/3 the size of our original QRST quadrilateral. And that is using dilations. You're either enlarging or shrinking a shape using a scale factor.